Now for part B. I'm starting with the same 70 grams of Q at 79 degrees Celsius, but this time I'm dropping it into ice at -3. Once I see ice and a temperature that's well above zero, I'm concerned that we're probably going to have a phase change. And in fact, ice is going to have to do a lot of things. It's starting at -3. It's going to increase until we get to zero, level off, and then keep increasing until we get to X. So in this problem, when I have Q, the heat lost equaling the heat gained, my Q term doesn't change. I'm still starting with 70 grams of Q. It's still a liquid, and it's still going to start at 79 and cool down to X, much like in the last problem. If you want to put it on your heating curve, it's doing something like that where they meet. The issue is the ice is doing three things. The ice is liquid warming up, it's melting, and then it's heating up to some final temperature. So I'm going to have a bunch of terms over here for ice. So first of all, I have 5 grams of ice. In the ice phase, it's going to go from -3 up to 0. Ice has a specific heat of 2.06, and this step is going to have a temperature change of 3. Then the ice is going to melt. For that step, I have mass times heat of fusion of ice. My third thing that the ice is doing is it's going to warm from 0 up to X. I still have 5 grams of it. Now it's not a solid anymore, it's a liquid, so I need to use a specific heat of 4.18, and it's warming from 0 up to X, bigger minus smaller. All right, let's simplify some stuff here. 70 times 1.2 is still 84, times 79 minus X. Then on the right side, 5 times 2.06 times 3 gives me 30.9. 5 times 334 gives me 1670. 5 times 4.18 gives me 20.9. And this doesn't matter, so 20.9x. I'm going to distribute on the left side. 84 times 79 is 6636 minus 84x. I'm going to combine these terms. 1670 plus 30.9 is going to give me 1700.9 plus 20.9x. To collect like terms, I'm going to add 84x to each side. And that's going to give me all of the x's on that side. I'm going to subtract 1700.9 from each side. So 6636 minus 1700.9 leaves me with 4935.1 on the left, and 20.9 plus 84 gives me 104.9x on the right. 4935.1 I'm going to divide by 104.9 to get x alone, and I get 47 degrees Celsius. This is indeed my final temperature, 47 degrees Celsius.